Hello everyone, today I'll show you segment anything model details which has been recently announced by the Facebook parents company Meta. And basically segment anything model can detect any object inside the image, and it also can generate segmented masks for each of the segmented part of the image. And today I'll show you how you can extract a specific part of the image from the original image using this segmentation masks generated by the same model. And before going to implementation, I would like to show you some basic information about the segment anything model. So here first question is, what is SAM? Basically SAM is recently announced by the Facebook parents company Meta on this April, and SAM has the ability to identify and the segment different objects within an image that has not encountered in its training. SAM is the zero-shot object segmentation deep learning algorithm, and SAM is prepared by SA1B dataset, and here you can see the link for the SA1B dataset. And basically it consists of 11 million high resolution and privacy protecting images and 1.1 billion high quality segmentation marks. And here you can also get some information about the SA1B dataset. Here is the number of images and the number of marks, and marks per images is 100, and and here you can see the image resolution. And the second question is how this SAM can helps developer and the researchers. So it significantly reduces the time and the resources required for the data annotation, which is often a major bottleneck for developing a computer vision model. And the researchers and developers can build more effective models that can adapt to new and unseen objects without retaining or additional level data. So here if I want to develop a new computer vision model that can detect this type of unseen object inside the image, so SAM can help us by annotating the image, and by labeling we can develop a new computer vision model that can detect this type of specific object that has not been seen in its training. So definitely it will reduce the time and resources required for data annotation and data labeling. So here is the basic idea how segment anything model can generate marks for each of the segmented part of the image with the information like the segmentation, bounding boxes, area, predicted IOU, stability score, probe box, and the point coordinates. So if we send this image to the SAM model, and SAM model will generate a binary marks for each of the segmented part with the following information. If I show you another image, it will be more clear for you. Here you can see an original image, and we manually can identify all segmented part of the image. Here you can see the segmented part 1, it is the segmented part 2, and it is 3, and here you can see the small segmentation part, maybe this is the 4. And if we send this original image to the SAM model, then SAM model definitely generate 4 segmented binary marks for each of the segmented part. So here you can see for the segmentation part 1, this is the binary marks, and for segmentation part 2, this is the binary marks, and for segmentation part 3, this is the binary marks, and for segmentation part 4, this is the binary marks generated by the SAM model with the information like segmentation box, area, predicted IOU, stability score, probe box, and point coordinates. For all of these 4 marks, SAM model will generate this information. Basically SAM model will return this result for each of the segmented part of the image. Here I would like to share you another things. SAM model basically generate marks using 3 ways. One is automatic marks generator. Using the automatic marks generator, if we send any image, then SAM model will generate marks for each of the segmented part of the image. And another way is if we send any point coordinates and the original image to the SAM model, then SAM model will generate marks considering these point coordinates, and it will return definitely this segmentation marks for these point coordinates. And another way SAM model can generate marks if we send any bounding box information to the SAM model and the original image, then SAM model will be generate marks for these bounding boxes considering these bounding boxes information and return the following result. So if we send this bounding box information and this image, then SAM model will generate only single marks like this. Before going to implement segment anything model in Github, we just need to change the runtime. From here, change current runtime, and here you can set the GPU and save. And then we just need to execute this first command, NVIDIA SMI. Here you can see the Tesla T4 GPU is assigned for me. And first here we just get the current working directory using this command, os.get current working directory. So this is my current working directory here, and we just need to install segment anything model in the current working directory by using this link. I'll give you all of the links in my video description box. Hope it will help you. and inside the home directory we'll create a weights directory for keeping all of the segment anything model weights. And we know that there are three types of segment anything model. One is vit ace for heavy model, and vit al for large model, and vit b for the beta model. Vit ace is the more accurate, but it is very slow. But vit b is lightweight and it is very faster. So basically I will download all of these three model weights for segment anything model inside the weights directory. So we just need to execute this, and it will download from this link and keep inside the weights directory. Here you can see the weights directory is created. If we click on weights directory, we can see here three model weights is downloaded inside the weights directory. One is vit A is for heavy model, vit L for large model, and vit B is for beta model. Now we need to move in the home directory and need to install some important packages like torch vision, supervision, and then we need to install torch vision. Then supervision. Basically supervision is for the visualization and the annotation. And here you can install opencv python. Opencv is python used for reading the image from the directory. And first we need to set the device. So this is the command, and we just need to execute, and we'll print the device. Definitely it will return the CUDA 0 because I have already set the runtime to GPU. So the output is CUDA 0, and here we just need to assign the use model type and the model checkpoint path. So first I will use vit b, which is beta model, and it is lightweight and the faster. So we just need to change the checkpoint path. For using this beta model, we just need to click here and copy the path, and we just need to paste it here. Now you can check it. Yes, it exists. Now we need to import SAM model registry, SAM automatic marks generator, and SAM predictor. SAM automatic marks generator is used to generate masks for each of the segmented part of the image, and SAM predictor basically two way can generate masks. One is if we send any point coordinates and the original image, then SAM model will generate marks considering these point coordinates. And another way is if we send any bounding boxes information and the original image, then SAM predictor will generate marks considering this bounding box information. So basically in these three ways SAM model can generate marks. So we just need to import all of this, and here we can initialize the SAM model. So it's working. There is no issue. Now we need to read image using CV2. For reading the image, we just need to upload image in this current working directory. To upload any image in this current working directory, we just need to click here. We'll just upload these two images. So basically this line will read the image, and we will need to convert this BGR image to RGB, and we'll keep a copy of BGR image to the original image and resize all of these three images. We can check the shape of original image. Here you can see this test image, this one, you can see the image here. So basically the test image, and we'll extract this card from this original image by using this segment anything model. So original image size was very high, that's why I have resized all of this image to 1024. Now we need to import the supervision to plot this image. Here we just plot this image here. We will generate marks using SAM automatic marks generator. For doing this, we just need to assign a variable marks generator, and inside SAM automatic marks generator we just send this model, this SAM model, SAM. We just need to send it here, and we need to send this RGB image to this marks generator. Then same model will return marks for all of the segmented part of this image. So here we will print the result keys first. Definitely here you will get the segmentations, bounding boxes, crop box, point coordinates. All of the information will get inside the result. So here you can see the segmentations, area, bounding boxes, predicted IOU, point coordinates, stability score, and the crop box. This information for all of the segmented part of the image. We can check number of marks generated by the same automatic marks generator by printing the length of the result. So print length result. Here you can see 73 marks generated with this information from this original image. So just now we need to keep all of this information like segmentations, area, bounding box, and the point coordinates. These four information will keep inside these four variables. That's why first I initialize this with blank, and inside the loop we will just append all of this result inside this four list. For all 73 segmentations inside the list, we'll store the bounding box, point coordinates, and segmentations, and the areas. So you can just run it. Here you can see the 73 bounding boxes information because I printed the bounding box here. And now we need to sort the segmentations, bounding boxes, and the point coordinates considering the areas. So here we just sort all of this information considering the area. Here you can see the area is used to sort all of this information like segmentations, bounding boxes, and the point coordinates considering the area. So inside the segmentation 0 we will get the largest marks, and we can use supervision to plot all of the marks. Using supervision we can plot all of the marks generated by the same model. So here you can see all of the marks. So the largest marks in the top, the car is the largest marks generated by the same model. We can also plot individual marks using here segmentation 0. So segmentation 0 is the largest marks generated by the same model. So if we plot the single marks, here you can see this is the largest marks generated by the same model. And also we can changing the list position, we can generate the second largest marks. So here you can see the second largest marks is here. Basically by changing the position of this list we can plot individual marks. So here you can see the marks for the door of the building. So basically in this way we can draw each of the marks from the list. Basically marks is the binary image written by the same model. If the image size is 1024 by 1024, then generated segmentation marks by same model is also 1024 by 1024. This is the segmentation marks for the door. So here you can see the segmentation marks is the binary image. So same model will generate 73 binary image for this original image, and which is basically the segmentation marks. And also it will return some other information like the bounding boxes, point coordinates, stability score, probe box, lots of information also same model will generate for this segmentation marks. Here we will draw using automatic marks generator for all of the segmented part of the. So we just need to execute this. Here you can see the original image and the annotated image, but the marking quality is not so good here. So if we change this beta model to heavy model, then definitely the masking quality will be improved. So for changing the model weight, we just need to go here, and here you can just replace the B by ace, hit ace, and we just need to copy this model path and paste it here, and we just need to run this. We just need to read the image again, and if we generate the marks using this bit ace heavy model, then we'll get more marks. Here you can see 111 marks. Previously we have got 73 marks, but here 111 marks for this original image. So definitely the masking quality will be improved by this bit ace or heavy model. And we can just execute this, and here we just need to sort all of this segmented information, and if we draw all of the segmented marks here, all of the 111 marks is here, and if we draw the largest marks generated by the bit ace model heavy model, then we can see here the building is the largest marks generated by same heavy model. So if we change it here just one, so second largest segmentation part is the color of this image. So in this way basically we can plot all of the marks individually by changing this position, list position, and if we draw all of the marks over the image and annotate it by the heavy model, then definitely we'll get the improved marks. Here you can see all of the segmented part is detected by the heavy model. We can remove the bounding boxes information by removing this line. So here you can see the good quality marks is here. Heavy model accuracy is very good. If we read another image like this color image, then what will happen, just I will show you. So just need to change here, just copy this path and paste it here, and also we can change the model to beta model, copy path and paste it here. So here we read the color image. Here we just draw this new image. Here you can see the four segmentation part of this image we can manually identify. This is the first part, second, third, and this is the fourth. So if we generate marks by same automatic marks generator, then definitely the length of the result will be 4. Yes, that means number of marks generated by this same automatic marks generator is 4, that we can manually identify easily the 4 segmentation part of this color image. So if we sort all of this information like bounding boxes, segmentation, point coordinates, and the areas. So before sorting we just need to keep all of this information inside this list, and here we just need to sort all of this information based on the area. And then if we will draw all of these segmented marks, here you can see the 4 segmentation marks. If we draw individual marks here like the largest one, so here you can just need to put 0, and here you can see the largest marks. So this is the largest marks of this image. We can also manually identify this segmentation part should be the largest one based on this area. Basically area is here in terms of the pixel. So if we draw the second largest marks, basically this should be 1 for the second largest marks. So this is the second largest marks. So now if we put it here 3, then we'll definitely will get the smallest marks, because total number of marks is 4. So here you can get the segmentation marks for this small portion. I think this is clear. all of the things about the segmentation of marks generated by the same model. We would like to show you marks generation by the same predictor. Basically, same predictor will take input point coordinates and the bounding boxes information. First, I'll show you how the same predictor can generate marks by using the point coordinates. So I have already stored all of the point coordinates inside the points variable here. You can see the points, segmentations, bounding boxes, and the areas. So here is the four all of these four bounding boxes information. Here is the 4 point coordinates of this respected segmentation. So and here inside the segmentations and inside the segmentations all marks is stored. So I will send a point coordinates inside the same predictor, and then definitely same predictor will generate the marks for considering these point coordinates. Here I just send point coordinates 0. That means the coordinates of the largest segmentation. Here you can see the marks by points inside the same predictor. We just send these point coordinates and the points label, and multi-marks output is false. Then what will happen? For this original image, 1 marks is generated by this point coordinates. We have already know the point 0 is the point coordinates for the largest marks. So if we draw this largest marks using supervision, so here you can see the marks is generated by this largest portion, and here is the bounding box information. If we change the point coordinates here 3, then the smallest marks will be generated by this same predictor. If we draw this, here you can see for this smallest portion of the original image same predictor generated marks. And what happen if we send any arbitrary point like 500, 500, then what will happen? Oh, we just need to send it inside the list. We just need to send in this way. That's why we are getting error. So 1 marks is generated for this arbitrary point coordinates. If we draw this, here you can see the marks is generated for the segmentation part 1. Maybe this original image size is 1024 by 1024, say. So 500, 500, maybe the point coordinates is over here. That's why marks is generated for this portion. So if we send like 1000, then maybe generate marks for this portion. If we send it here 1000, 1000, as the image size is 1024 by 1024, so here you can send 1000, 1000, then what will happen? So here you can see the marks plotted over the largest portion, because the original image size is 1024 by 1024, so definitely 1000 by 1000 point will be here. So this point inside this largest segmentation part, and here you can see the marks is generated over this portion. Now I'll show you generating marks using the bounding box information by same predictor. So here we can use the bounding box information for the largest segmentation. So boxes 0 is the bounding box information for the largest segmentation. So here we just send the bounding box information, and the point coordinates is none, and the generated marks is 1. If we draw this marks, then here you can see the marks for the largest bounding boxes. If I read the another image, test image, and we will draw the marks using the point coordinates and the bounding box information for this this image. I will use same predictor, and using the point coordinates and the bounding box information I will draw marks over this image. So we just need to again execute all of these codes. Here you can see the generated marks is 73 by the beta model, and here you just need to sort all of this information based on the area, and we don't need to plot all of this we don't need to plot all of these marks. I have already shown you. So here we can just save the largest marks. Here you can see the car is the largest marks by beta model, and now I'll show you how you can generate marks using SAM predictor for this test image using point coordinates and the bounding box information. So first I will show you using the point coordinates. So if we generate the largest marks, we just need to put it here 0 and run it. Then definitely the largest marks for this image will get by the same predictor. So here you can see the number of marks is 1, and if we plot these marks, here you can see the car is the largest marks for using this beta model for this original image. So here you can see the annotated image, and here we use the point coordinates. So now if we use the bounding box information, then what will happen? So here if we use the box 0, box 0 is the largest bounding box information. So if we execute this and just send the bounding box information, and the point coordinates is none here. So if we plot this here you can see the annotated image using annotated image for these marks. Now I will show you how you can extract the specific part of the image from this original image, and how I can draw it over the white background. For this we just need to execute this code. So here is the basic things of supervision, and if we put it here, the segmentation 0 is the largest segmentation part, and we need to check first we need to check, and then I will explain all of the things over there. So here you can see the original image, and this is the annotated image, and here the segmentation marks, and here is the segmented image. Basically I extract this segmented part of the image and draw it over the white background. So basically this line is we know that the segmentation is the 2D binary image, so we just need to convert this binary image grayscale image, and then we need to convert this grayscale image to BGR image. After that we need to perform a bitwise operation with this segmented image and the image BGR, that means the original image. If we plot this segmented image 1, if we remove this line, and draw this segmented 1 image, then what will happen? Here you can see the car is here, because we have performed a bitwise operation between this image and this image, original image, and this original image and the segmented marks, if we perform this bitwise operation, bitwise AND operation, here you can see the bitwise AND operation, and this will return basically this image. In the last line, we just convert all of this black pixel using the white pixel. So easily we can extract this image for the segmented part of the image, and here you can see the black image is replaced by the white image. So this is the basic idea how we can extract any segmentation part of the image